Welcome to today's tutorial. So in this tutorial I'm going to be solving a question from Thomas exercise. This is exercise 19 to 22 from chapter 3.2. So the question is asking us to find the values of these derivatives here. So in case you have not yet subscribed to the channel, make sure that you do so, and don't forget to click on the notification button so that you get notified about every video that I'm going to be posting. And you should also know that there are videos that I have put on private. They are only visible to specific individuals. So if you want to have access to such videos, you can simply just contact me, more especially on limits, calculus. There are videos that are private. You can contact me on any of these lines, and then I'll give you access to such videos. Alright, so let's quickly begin to solve. Alright, we have ds dt is equal to this. That's the question. So the expression for s is simply just 1 minus 3t squared, and then we've been asked to find ds dt. So to find ds dt, how do we do that? How do we find ds dt? So ds dt, in this case we're going to use the power rule. So to find ds dt, we're going to have, so the derivative of any constant is simply just 0. So the derivative of 1 there will give us a 0. Then the derivative of negative 3t to the power 2 simply just be found by multiplying the power to the coefficient of t, which is just going to be negative 6. And then when we say 2 times negative 3, we get negative 6. And then we say t raised to the power 2. And then we subtract 1 from 2, which will give us 1. So when we say 2 minus 1, the answer will simply just be 1. So ds dt will simply just be equal to negative 6t. So negative 6t is ds dt. So now they're asking us to find ds dt at t is equal to negative 1. So ds dt at the point where t is equal to negative 1 is simply just equal to we say negative 6, and then while there's t there, we're going to put negative 1. It's just a matter of replacing negative 1 while there's t in the expression for the ds dt. That's all. So negative 1 times negative 6, the answer is simply just 6. So this is the solution to the first part of the question. Let us quickly move on to the next part of the question. So the next part of the question is asking us to find dy dx, given that the value of y is equal to that. So let me start from here. Okay, let me just do it from here. So y is equal to 1 over x, 1 minus 1 over x. So this can also be written as y is equal to 1 minus x to the power negative 1. So to find dy dx, dy dx of every constant number is simply, or the derivative of a constant number is simply just equal to 0. And then negative 1 times the coefficient of x, which is negative 1, will give us positive 1. So positive 1, we have positive 1, and then we say times x, then we say negative 1 minus 1 there to give us negative 2. So dy dx is simply just going to give us 1 over x squared when you take this back to the normal form, which is in this form. Okay, so so from there, this is what we have. Now let us find dy dx at the point where x is equal to the square root of 3. So we find dy dx at the point where x is equal to the root of 3. So this is just going to be equal to it's just going to be found by replacing the square root of 3 where there is x there. So I'm going to have 1 over the root of 3, then this will be squared. So this will be 1 over 3. So 1 over 3 is going to be our solution. So let's quickly move on to this one. So I'll leave one question for you to practice. So I'm going to do this one. I'm going to do this one, and then you send the solution for this one. as a practice exercise. Okay, so let's do this one. So this one we have, this is question 21. Then we've been asked to find the r d theta when theta is equal to 0 of this expression. So the value of r, or the expression for r, is given as 2 over the square root of 4 minus theta. So this is the expression for r. So now to find the r d theta, we simply just have to we simply just have, if you want, you can use quotient rule. You will still get the same answer as what I'm going to get. So this r can also be written as 2, and then open brackets the square root of 4 minus theta, and then raised to the power negative 1. So if you have such an expression, you can also write it as, so I'm just trying to simplify the expression, but if you want, just from picking this expression here, you can use quotient rule. You take your numerator as your u, and then the denominator as your v. So you're going to have 2, and then you are going to say open brackets, you have 4 minus theta, then close the brackets, then you have negative half as the power this side, because you know that anything raised to the anything that has been square rooted is just the same as raising that expression to the power half. So that power half times the negative 1 outside there, you get negative power half. So we can now differentiate this. So to find the r d theta, we use chains rule, since this is now this is now a function. This is now a composite function. So we have two functions. The first function we have is inside there. The other function that we have is just the whole function there, the function of r. Yeah. So chains rule is used to differentiate composite functions. So let us differentiate this. So we use the shortcut for chains rule, where I just multiply, which is just similar to the power rule. So you multiply the power to the coefficient of what you have there. So negative half times 2 there, you're going to have negative half times 2, negative half times 2. The answer will give us what? So the answer will give us negative 1. So we're going to have negative 1 there. Then we're going to multiply the negative 1 to the derivative of what we have inside. So the derivative of 4 is simply 0. The derivative of negative theta is simply just negative 1. So I'm going to write my negative 1 there. And then from there, I'm going to write the whole function, the whole expression there, which is open brackets 4 minus theta. I'm going to write this, then raised to the power. This half, I'm going to subtract 1 from the power. So when I subtract negative half, when I say negative 1, rather negative half minus negative 1, the answer that I'm going to get is simply just negative 3 over 2. Yeah, so I'm going to get negative 3 over 2 as the answer. So negative 1 times negative 1 there, the answer is simply just going to be equal to positive 1, and then we're just going to remain with that as expression for the r d theta. So this one can also be written as open brackets. We have 4 minus theta to the power half, and then everything raised to the power negative 3. So anything raised to the power half is just the same as the square root of that thing. So we have the r d theta is equal to this raised to the power half is just the same as the square root of what? The same thing, which is just 4 minus theta. Yeah, so and then we raise this to the power negative 3. So if you use quotient rule, you still get the same answer as what I've gotten here. So the r d theta will now just be equal to, so the r d theta will now just be equal to, when we take this as a denominator so that we get rid of the negative there, we'll just have 1 over the square root of 4 minus theta, 4 minus theta, then everything raised to the power 3. So this is what you are going to have as the expression for the r d theta. So if you want, you can simplify this further. Let me see where I can simplify it from. There's no space here. Okay, I don't know if you'll be able to see what I'm going to. Okay, I'm sure you see. So simplifying this further will give us the r d theta as 1, to give us the r d theta as 1 over, forget about this, so just consider this 1 over, that will give us 4 minus theta, then multiplied by the square root of 4 minus theta. Yeah, so this is this is the other way you can simplify this expression. Yeah, so now we've been asked to find the value of this same answer that we found here, when theta is equal to 0. So when theta is equal to 0, just replace 0 where there is theta there. So when you replace 0 there, you're going to have, let me just erase some things here. So the expression for the r d theta gave us 1 over the square root of 4 minus theta, then everything raised to the power 3. So now to find the r d theta at the point where theta is equal to 0, the answer is supposed to be found by replacing 0 where there's theta there. So we have 1 over the square root of 4 minus 0, then everything raised to the power 2. This is just the same as 1 over the square root of 4, and then everything raised to the power 0, because 4 minus 0, the answer will still be 4. And then the square root of 4 is simply just 2. So 2 raised to the power 3. Oh, this is 3, not 2. 2 raised to the power 3. So we get 1 over 8 as the answer. So the r d theta, when theta is equal to 0, the answer is simply just 1 over 8. So you can also try to solve this one. Then when you are done, you can send me the solutions so that I see and confirm whether you're correct or wrong. Alright, so thank you very much for watching today's tutorial. So if you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button and also click the notification buttons. Like I said at the beginning, there are videos which are private, which I can't give to everyone. So if you want to have access on such videos on calculus, of course, limits, calculus, and also other topics. So if you want to have access on such videos, feel free to contact me on any of these lines and tell me that you want to join the group where I've given access to all the videos, and I'll give you directions and what to do for you to join the group. Okay, so see you in the next tutorial video. If you have any questions, feel free to contact me on any of these lines. My name is Harmtedy. Shalom.